Some investments don't stay at the same rate the whole time. When the interest rate changes, each period must be calculated separately using the compound interest formula. Here I've prepared two examples where we apply this concept. In question number 1, an investment of $2,500 earns interest at 4.5% per year compounded monthly for 3 years. At that time, the interest rate is changed to 5% per year compounded quarterly. How much will the accumulated value be 1.5 years after the change? Let's begin with a reminder of the future value of compound interest formula. It looks something like this. Future value is equal to your present value. We represent that as P times 1 plus your interest rate per period I raised to the power of n. You can also break down I into R over T, which is your nominal interest rate divided by the number of compounding periods per year, and n can be written as the total number of years multiplied to the number of compounding periods every year, which we said was T. So for the first 3 years, we have an interest rate locked at 4.5% compounded monthly. Let's go ahead and find out how much our investment matures in the first 3 years. Then we can worry about the other rate. So our future value in 3 years from now is $2,500 multiplied to 1 plus our interest rate of 4.5%, which is 0.045, divided by, we're compounding this monthly, so T must be equal to 12. And we raise this to M, which is the duration, 3 years, multiplied by 12. So the future value, 3 years from today, using our calculator, can be found by taking 2,500 times 1 plus 0.045 divided by 12 raised to the power of 36. And we end up getting 2,860.62. Now after this term ends in 3 years, we now have a new interest rate of 5% compounded quarterly. And this will be happening for 1.5 years. So that will be our new value of M. Our new nominal interest rate is 5. And our value of T, because it's quarterly, is equal to 4. So let's find our new future value. We'll call it FV sub 1. Our new principal as well is 2,860. So we'll be using this amount as our new principal, 2,860.62. And that's being multiplied to 1 plus 0.05 divided by 4. We'll now take an M value of 1.5 and multiply it by 4. Now, if you want to maintain accuracy, you can keep the value on the screen and use that as your principal, or you can use the newly rounded version. I'll go ahead and use the newly rounded version, 2,860.62 multiplied to 1 plus 0.05 divided by 4. Raise that to the power of 1.5 times 4. Now, if you're not using this particular brand calculator, you may want to put the exponents in parentheses. And we end up getting a future value after 4.5 years being 3,081.98. So $3,081.98. Let's try another question. Accumulate 1,300 at 8.5% per year compounded monthly from March 1, 2020 to July 1, 2022, and thereafter 8% per year compounded quarterly. What is the amount on April 1st, 2025? So let's find the future value for the first term that lasts from March 1st, 2020 to July 1st, 2022. Using the future value formula, FV is equal to a principal of 1,300, 1 plus our nominal interest rate is 0.085, and we'll be dividing that by 12. That will be raised to an M value that's unknown to us times 12. Remember, N is equal to M times T. T is 12. So we need to find M. To find M, you can create a quick timeline. So we have March 1st, 2020, and that extends to, let's say, March 1st, 2022, which is a few months before July. And the duration from these two dates is 2 years. Simply subtract 2020 from 2022 and you get 2 years. Now from March, which is the third month of the year, to July, which happens to be the seventh month of the year, is 4 months. So to write our value of m, we'll say m is equal to 2 years and 4 months, but m needs to be in years. So writing 4 months in years is as simple as taking 4 divided by 12. There are 12 months in a year, and 4 of them have passed. So that's our value of m. Let's go ahead and put that into our formula. 4 over 12 times 12. Okay, let me show you how to use your calculator to compute this. We have 1300 times 1 plus 0.085 divided by 12. We open up exponents, and we have a mixed fraction here. You can change that into an improper fraction by hand and then substitute it into the calculator, or you can use this special feature on this calculator and actually type in 2 and 4 over 12. So I typed in a mixed fraction, and then I multiply that by 12. And this gives me a future value after 2 years and 4 months of 1584.07. Now we need to find another future value where the interest is 8% compounded quarterly leading up to April 1st, 2025. So now the timeline is July 1st, 2022 to April 1st, 2025. We'll call this future value FV sub 1. Our new principal is 1584.07. 1 plus our new nominal interest rate is 0.08, and we're dividing that by 4, and we're raising this to m times t, which is 4. Now we need to find m again. Let's continue our timeline. We have from July 1st all the way to April 1st. To find this duration, I'm going to extend my timeline just a little bit so that it extends to July 1st, 2025, which is only a few months after April. If that were the case, then it would be 3 years from here to here. But it's not. So next we can find out the months that passes from April 1st to July 1st. July happens to be the 7th month of the year. April happens to be the 4th. 7 take away 4 is 3. So this is 3 months, which I will be subtracting from 3 years had it been from July 1st, 2022 to July 1st, 2025. That means the duration is 2 years plus 9 months. 12 take away 3 is 9. Writing this down in years, we have an m value of 2 and 9 over 12. Let's substitute that in for m. So 2 and 9 over 12, which, by the way, is the same thing as 2.75 times 4. So let's find our final future value. The number on our screen times 1 plus 0.08 divided by 4 raised to the power of 2.75 times 4, and we get our final future value of 1969.59. If you have any further questions about what we just learned, feel free to use the comment section below. Thanks for watching.